So pretty much everyone agrees that working with databases is hard. There are three things that I hate doing in particular when working with relational databases. One is managing and migrating your schemas across environments. Two is writing SQL queries in general. And three is writing those return types for all of those SQL queries and working with TypeScript, which feels like doing the same work all over again. However, with the next generation ORM like Prisma, all of that is essentially solved for. Especially when used with a convenient database provider like Supabase, everything suddenly just works. In this video, we will talk about Prisma and Supabase setup, schema definitions, migrations, local development, and much, much more. All code is available on GitHub. Link is in the description below, so make sure to check that out. That being said, let's dive right in. So grab a drink and let's get coding. First off, let's install Supabase locally so that we have a database to work with. Supabase is essentially a database as a service provider that focuses really heavily on providing a great developer experience locally and remote around their PostgreSQL database. An alternative that you could also use is PlanetScale, which offers a MySQL type database, but I personally prefer the experience of just working with Supabase. First off, make sure that you have Docker installed and running. You can check that by running the command docker ps. And if you see that the Docker daemon could not connect, you can just open the Docker desktop version. Or if it says that the command docker is not found, that probably means that you don't have Docker installed, in which case you can just visit the Docker website, click on Get Started, and install Docker for desktop. What Docker does is it essentially enables you to run containerized applications on your machine. Now these applications are executed in their own self-contained virtual environment so that they aren't impacted by your own system, operating systems, or settings. The reason that Docker is required for Supabase is that the Supabase instance is configured to run within a Docker container itself. So once Docker is up and running, let's just run the docker ps command again. We see we get a positive output, is that we can set up our own directory and project. So let's just make a new directory called Supabase Prisma and cd into that. In here, we can install the necessary dependencies, which first of all is TypeScript and the types for Node, which we will be using later as well. We will be using these as dev dependencies as we simply need them for compiling this project. And finally, we can also install Supabase, which for now we will also only be installing as a dev dependency, as for now we are mainly using the CLI options, which we don't need to deploy with our application later on. Now that we have installed the Supabase CLI, we can run this npx supabase init command to initialize the setup. What this does is, if we open this up in our code editor, is that it creates a Supabase folder, and inside the Supabase folder you will see two files. One is a seed.sql file. This file will be executed anytime you start up your local Supabase instance, and it will do just that. It will seed your Supabase database with the tables and data that is configured here. There's also a config file that specifies the port and settings for our Supabase instance. We also have some config for things like storage and auth, which we won't be concerning ourselves with this time, as we will simply be focusing on the database component itself, and that can be used in isolation, so we don't really need to worry about this at all. Now back to our terminal. Once you have run Supabase init, you can run the command supabase start. And what this will do is it will pull the necessary images from the container registry, essentially the Supabase images. And once they are successfully pulled, it will start up our Supabase container. This will take some time once you do it for the first time, because these images are quite large, but any subsequent Supabase start commands will run significantly faster as these things are stored locally. If you get an error message saying that it cannot connect to the Docker daemon, then you probably haven't started Docker correctly, so go back and fix that. If you get an error message that Supabase is already running, you need to navigate to that project and make sure you run the Supabase stop command. In case that project no longer exists, because you've deleted it, for example, and Supabase is still running, it's a little more difficult. You can go through the Docker UI and kill all of those processes manually. But there's also this neat command which you can run, which I'll just copy paste in the terminal here. And you will find that in the description below as well. Essentially what it does is it looks for any Docker containers with the name Supabase, and it will make sure to close those and remove them. So let's just go back to our old terminal. And I will fast forward until the download is completed. Okay, here we go again. So the entire process probably took something around 4 to 5 minutes, and in total something like 2 gigabytes of memory were downloaded. There is a lot of very interesting output here, which we will go through one by one. And the first one is the Studio URL, which we can just copy and paste in our browser. This interface is very similar to the Supabase website and provides a nice UI to manage your database. Our Studio shows that a default project has been created. One thing to note is that Supabase running locally only supports a single project at the time of this video. First off, let's take a look at the table editor, where you will see that within the public schema, no tables have been created. Actually, let me zoom in a little bit here. Right, so you have the public schema here and no tables that have been created. Supabase also internally creates a few other internal schemas, for example, for authentication and storage utility, etc. But we don't need to concern ourselves with that at the moment. We also have an SQL editor, which is convenient for testing some queries if we ever need to write custom SQL. And we also have a database manager itself that allows us to manage things like roles and row level permissions, which we don't see right now because obviously we haven't created any ourselves yet. So back to our prompt. There is some more information in here that's super valuable for us. First off, there is the API URL. So what Supabase does, it creates a data API that you can interact with using the Supabase client directly from the front end. It's a little like a GraphQL API that you might be familiar with. This also includes an authorization layer if you're using the Supabase authentication mechanism. But what if you want to use the data API but don't want to use Supabase Auth but want to use your custom authentication provider? Well, that's where the JSON Web Token secret comes in. Locally, this is a hard-coded string, but on your production instance, this will be a randomly generated string of the same length. Now, this comes in handy when you are using another authentication provider, for example, NextAuth, and you want to generate a JSON Web Token or in form of an access token that you can then pass to your Supabase client on the front end to talk directly to your data layer, so that you can create a token that the Supabase backend recognizes and trusts and manages then the authentication and data access automatically. You will find that there are also 2 JSON Web Tokens generated here. These have 2 purposes. One is the anonymous key. The anonymous key can be used to run commands against your data API, so this one over here, if you don't have a logged-in user. So, for example, imagine a blog scenario where any public unauthenticated user should be able to read posts, but only authenticated users should be able to create posts. In that case, you would be using the anonymous key to retrieve those public posts, and you would use the personal key of the logged-in user to create a new post, for example. The service role key is something that you want to be very protective of, especially for your production instance, because what this is it's a key with elevated privileges. So this essentially acts as a super user or an admin user and can perform any operation on your database. This is super useful if you have a separate backend, for example, and that you have an authentication layer between your front end and your backend. And then essentially your backend can just do whatever on the database itself. So then this might be the key that your backend would be using. It is important to understand conceptually that both of these keys work with the data API provided by Supabase. And if you're using the Supabase client to perform some interactions on your database, then these keys will be helpful. If you have a backend, for example, that operates on the Postgres database directly just using SQL queries, for example, has a direct established connection, then of course you probably don't need these keys. But what if you don't want to use the Supabase data API, but instead you want to connect directly to your Postgres instance? Well, for that purpose, you have the database URL, which contains your database user, your database password, which is on your local setting hard-coded, but on a remote setting will be randomly generated, and the URL or location where your database can be accessed. Now, this is exactly what we were using when we create our Prisma client. And speaking of, let's actually set that up. First off, let's install the Prisma dev dependency. The reason why this is a dev dependency is that we only need the Prisma CLI for now, and we will install the Prisma client for actual querying later on. Once we've installed Prisma, we can run the npx prisma init command. And this will prompt you with what it's doing, but essentially if you open this up in your code editor, you can see that it has created a .env file. And actually, let me close this .env file from a previous iteration. Here we go. And this .env file contains the connection string to your database. Now it has just randomly generated something, but what we can do is we can actually copy paste over the Postgres database connection URL that Supabase has just generated for us. So let's do that and hit save. We also see that it has created a Prisma folder. And in this Prisma folder, we have a schema.prisma file. And this is what we'll be working with most of the time when we are working with the Prisma schema itself, because this is where you define what your tables should look like and what your data entity should look like and what relationships they have to one another. So in effect, what this will do is it will contain the shape of your database, and it will also be the single source of truth from which Prisma will generate all of your types later on automatically to be used in your application so that you don't need to manually type your responses. Now, what I highly recommend you have is that you install the Prisma VS Code extension. For that, you can simply on the left here go to your extensions and search for Prisma and install this extension. And what it will do is it will make working with the Prisma schema a lot easier as you get syntax highlighting, auto formatting, code completion, etc. So it's a very, very useful tool to have. So in Prisma, we create new tables as models. So one example of that would be a model for a user table would be created like that. The reason that Prisma in their schema files chooses a different name other than table is because Prisma is database agnostic. So you can actually use this for your Postgres database, which has tables, but you can also use this for MongoDB, which might have collections. So that is why the naming here is a little different, and we need to translate what that means for our Postgres database. So let's create a simple scenario where we have a user, we have blog posts. So let's just call this post, and we have comments. And users can create posts, users can create comments, comments are linked to posts. So it's a very, very simple scenario. To define the fields of our table, we create a new line. And in this new line, we define the name of that field. So in this case, let's go with ID. And this ID field is of type string. What Prisma also provides is a few attributes. So for example, we can add the ID attribute, which marks this field as the primary ID, which has a unique constraints on all of its entries. We can also do the same for posts. So let's also add the ID here. And we have the same for comments. Now, there are also a few more attributes that you can add. For example, we can add with the add DB modifier, we can add the UUID. What this does is Postgres has a specific type for UUIDs, which will ensure not just the uniqueness, but it will also ensure the format of the string itself. And with this add_db prefix, what you're essentially saying is this is something that's specific to whatever database we provided up here. So by saying that our provider has a PostgreSQL database, we have access to the UUID type of field. Now, what Prisma also supports is default fields, right? You remember that when you create a table and you would generate a new ID, that, for example, you could have an auto-increment ID. And in our case, what we want is we want to have a randomly generated UUID every single time. So for that, we have the default attribute. And in this default attribute, we could specify UUID directly. But what this will do is it will only implement this on the Prisma client level. So later on, when we generate our Prisma client to perform our actions from the schema, then Prisma will make sure that every new entry has this UUID generated. But this isn't actually implemented on the database level. So if we use the Supabase client, for example, we need to manually generate this UUID because it isn't set on the database level. What we can do instead is we can use the dbGenerated function to specify a function that the database itself calls. And Postgres for this has a genRandom UUID function, which when called will do exactly that. It will generate a random UUID for us, no matter what client we use to create this entry. So let's add a few more fields. So a user can also have a name, which is of type string. It might contain an email, which is of type string. A user might create certain posts. So let's have a posts link here, and we reference that to our post table. So what we can do is we can just define the type as an array of post. And this will establish the connection. We need to actually define the link to that in just a second. But for now, we'll just leave it at that. And we already get some marks here that it isn't clear how that relationship is established. Now we can also add comments, which again is a similar relationship. A user can create multiple comments to multiple posts. On the post level itself, let's copy paste all of the UUID setup that we had on our user and add that to comments as well. So we make sure that we have UUIDs throughout. Next up, a post might have a title, which also is just a string. It might contain some text. It might also have a created at, which is a datetime, which in and of itself is also a supported format. And once again, we want to make sure that this field is always set, and it's always set to now. So once again, we can use our default attribute. We can use our dbGenerated attribute to make sure that this is generated on database level. And Postgres has the now function, which we can use to set up that datetime. Finally, we have a link back to the user. So we have our author, which is of type user. And we also have an author ID because we need to establish that link somehow. So let's just add author ID, which is a string. But we need to make sure the user ID is not just a string, but it's also a database UUID type. So let's add this one as well. So maybe we ensure that those types match. Now we get a little error message here that user needs to be defined further. So we can do this, add this by adding a relation, specifying the field that establishes this relation, which in this case is added as a list. So a list of just a single entry. And we establish to what field in the user table this references to. So the author ID here should be equal to the ID field in the user entity. So let's just add that as well. And there's actually one more error. I misspelled user here. It's of course lower caps. We can carry the same thing over to our comments. Now, comments, of course, also have a relationship to a post, right? So let's also add the comments to our post itself. So we have comments, which is just a list of comment. And on the comment side, let's add the post. So in this case, we have a post. And we have a post ID, which again is of type string, but with the UUID modifier or attribute. And again, we need to define the relationship here. So let's add the fields. The local field is the post ID, and the field on the post itself, object itself, or table itself is the ID field. Now, what we have here is we have one-to-many relationships, right? So a user has multiple posts or can create multiple posts, and a user can create multiple comments on multiple posts. There are, of course, also many-to-many relationships, and we'll get back to those in just a second. Now, make sure you save the file, and let's head over to back to our terminal. Because what we want to do now is we want to use the Prisma CLI to push our schema into our database to make sure that all of the tables, the fields, and the necessary relationships are built. For that, there is this command called npx prisma db push. There we go. And what this will do is just that. It will take your schema, it will push that to the database. But what it will also do is it will generate a Prisma client for you and install the Prisma client dev dependency, which if you go back to your code editor and look at the package.json, you will see the Prisma client added, sorry, not as a dev dependency, but as just a standard dependency. Because this client is created with all of the types that are necessary for you to interact with that database. You can also take a look at that package by opening up your node modules by going to add Prisma client. Let's just open any file, the index.dts, for example. And if we click on that import, we can see that we have our user, our post, and our comment types all set up. If you scroll down, you will see that there's actually a lot of that going on. So the Prisma type generation is no joke. They really are extensive. And that's what makes Prisma such a great library to work with, because no matter what you do, your types will almost certainly match your intentions without having to write any on your own. But let's just close out of all that, because we will see the types in action later on. What I want to draw your attention to is the db push command. So I mentioned that we only use db push during local development. So you might be wondering what you would use in your typical production workflow. The main difference between local development and production is that in local development, we treat our data as disposable. So any changes we might have to our schema, if we lose some data, that's not a big deal. However, in our production environment, we need to be a lot more careful with that. And that's why we have migrations. As you sort of evolve your schema quickly and iterate on that locally, you can always use db push to make sure that your local database is in sync. But once you have completed that step, once you're ready to commit those changes, you will want to create a migration. Doing these migrations is a two-step process. In the first step, you are creating your migration files, which is just SQL code that takes a look at your previous state, your current state, and generates the necessary SQL code to migrate from that previous step to the current step. The second step is then during your deployment process and your deployment pipelines, ideally, you will run those migrations against your remote database to make sure that those schemas match as well. To create a new migration, we can again use the Prisma CLI. And all you have to do is you have to use the migrate command, the dev command, which says that this is a migration creation, and we specify a name for that migration. So let's just call this database init because we don't have any previous migrations. Now you will get a warning here, which we can just ignore. It's essentially just telling us that our currently deployed schema does not match up to the previous migration. And in this process, there might be data loss involved. This is something that always happens if you run db push before db migrate. In this case, let's just hit Y and continue. Now, if you go back into our code editor, we can see that in our Prisma directory, we have a migrations folder that was created. And within this migration folder, there is another folder which contains the current timestamp and the name of the migration that we provided, in our case, database init. And here, all you have is a SQL file, which if you walk through it, it creates the database table, the user table, the post table, and the comment table, and it creates the foreign keys to establish those relationships that we defined in the schema previously. Now that we have the migration file completed, let's actually take a look at the database to make sure that it was updated as intended. So we can open up our Supabase Studio again via the URL that was provided earlier. By the way, if you ever forget these URLs, you can at any time run Supabase, I think it was status. Yeah. And that will provide you all of the URLs and all of the information again. So you don't need to actually stop and start your Supabase instance again. Anyway, so going back to the Supabase Studio, we can refresh the page. And on our tables, we can see, let's actually go to the table editor because that's a cleaner UI here. We can see that we have our users table, we can see we have our post table and our comments table. And we also have a Prisma migrations table, which lists which migrations have already been applied. And this is how Supabase internally keeps track of which migrations have already been used, so that when you add new migrations, it makes sure that it doesn't rerun ones that it has already executed. Speaking of migrations, how would we actually run these migrations? So right now it doesn't make sense to run them because they've already been applied here. The schema already matches. So in order to create a scenario, for example, how we might want to deploy this to a remote database that has no schemas applied to it at all yet, let's just simulate that scenario by stopping and restarting our Supabase instance. Because the default behavior from Supabase is that if you stop your instance and you restart it, it essentially resets completely. It drops all tables, drops all data, etc. There is a way to get around that, which we'll talk about in just a second. But right now, this is exactly the behavior that we want. So let's just give that a second to start up. So now that our Supabase Postgres database is just completely empty, we can try running the npx Prisma migrate deploy command. And this will run all of your migrations in sequence. Currently, we only have one. So we can see all migrations have been successfully applied. And we can open up our studio again, refresh the page, and we can see all of our tables back up and running. So this is exactly what would happen in your remote deployment. This is the command that you would usually run as part of your CI/CD pipelines, just executing the Prisma migrate deploy command. An example of how these migrations would be applied sequentially is, for example, if we take a look at our schema and we say, hey, we want to add to our users and posts, there should be some sort of upvote functionality, right? And this is where we get into many relationships, because a user might be able to upvote many posts and a post might be upvoted by many users. So let's add something like liked posts here, which again is a list of posts. And on the posts, we have a liked by, and we have a list of users. Now we get into an issue here because Prisma is not able to differentiate between this posts and this list of posts, right? So these relationships aren't named, and that's what we can introduce now. So we can, into this many relationship, we can add a relationship, and this has a name property, and this name might be liked posts, and we add this same relationship over here. And now it's able to disambiguate between these two. And as this is a many-to-many, we don't have to specify a field that establishes reference here. Instead, what happens is if we run, let's actually run migrate directly. So we have migrate dev and added liked posts. And we see that there is a new table that was created called liked posts. And the way that these many-to-many relationships are established is that it creates a new table where entity A refers, in this case, probably to users, and entity B to your posts. And that's how these many-to-many relationships are established under the hood, which is complexity that you as a developer don't need to worry about, which is super cool. We can also see that if you go back to our code editor, that in the migrations directory, there's now a second migration with the added like posts name. And if we were to stop and start the database again and run the migrations deploy command, then first of all, the database init migration would be applied, and then following the added like posts would be applied. So I mentioned earlier that the default behavior of Supabase is just on stopping and restarting your instance to drop all tables and all data. Now, this default behavior might change in the future, but at the time of this video, there is a way to circumvent that. So if you run the npx supabase stop command with the backup option enabled, then it will store all of your tables and all of the data that you currently have on the Supabase instance and save them to a Docker volume. The tricky part here is that if you start it again, and let's just do that, and then stop it again and forget the backup option once, then all of your data and all of your tables are gone again. That is the reason why I would never actually do anything within the Supabase Studio UI directly in terms of creating data or setting up those tables, but do everything via Prisma so that you are able to recreate those at any point in time. Now, this time I stopped using the backup flag and I restarted Supabase. So if we go into our studio and we refresh, we can see that we have all of our tables, even though we stopped and restarted the server. You might want to create an npm command to do the stopping and starting for you, which is something that I used to do. So if you go into the package.json, and you have the scripts, and then you have just the db stop, and then the db start, then you can just forget about the Supabase functions or commands in and of themselves and just use your own npm commands. And you never run into this issue that you might forget the backup ones. However, that still doesn't eliminate the need for us to at least seed a lot of data at a certain point in time, to do that in a way that can be shared and recreated by others for testing and code development purposes. And also, we really want a backup in case we forget this command, so that if we painstakingly create all of our testing data manually, and then we forget the backup once, that we have to recreate it all over again. So let's now use Prisma in order to create a seed for our table, for our tables, so that we have some users, some posts, and some comments to work with. To get started with our seeding data, let's go to our Prisma directory and create a new file. We call this file seed.ts. Let's reduce the size here a little bit. And this will simply be a TypeScript file utilizing the Prisma client to create our necessary data. We can also add in our package.json, under Prisma, we can add a command called the seed command. And all this will do is this will use ts node and call that to execute our seed.ts file within our Prisma directory. And this Prisma seed setup, that's something that's implemented on the Prisma CLI side. So to get started, let's get back to our seed.ts file, import the Prisma client, and instantiate that. Now, we want to create 3 functions that provide the raw data for our users, our posts, and our comments. And then we'll just have a main method that calls those functions to get the data, establish the relationships, and then use the Prisma client to push these out. So first, let's create this function called getUsers. And this function will simply return from our Prisma client, our user create input. And you can already see the strength of Prisma here, that it has already created that for us, and we don't need to do any manual typing ourselves. So what this will do is it will simply create an array, return an array, and these will contain the fields email, so test@mail.com, and a name, let's call this one Bob, And the relationships in terms of authors and liked by, etc., are established from the posts and the comment side, not from the user side. So let's just copy paste this once or twice, call this test 1 and test 2. Let's call this one Steve, and let's call this one Charlie. And add the commas at the end as well. Cool. Now we can do the same with the posts. Const get posts. This doesn't actually create anything with Prisma, right? We are just getting the data entities that we can then use with our Prisma client to actually create them. And the reason we are defining these as functions is because our posts are dependent on the users, right? So the posts, we need the author ID, which is an ID that is generated only when the user entity is actually created. So we don't know that beforehand. So we first need to create the users, then we need to take that response, extract the user IDs, and use that in order to assign posts to them. So this get post does exactly that. It takes in a list of users, and this user is also already typed in our Prisma client, so we can just import that. And what this will return is Prisma post create input. And you can just at any time, for example, if you just type post or any entity that you have, cycle through all of the many type definitions that Prisma has created for you, which is just super useful and gives you a very good understanding of the different use cases that Prisma is already thinking about. But for now, let's just use the create input. Again, we want a list. And here we have, let's just say we have two entities. In this first case, we have an author. And this author is the connection that is established right to one of the previous users. So we can just call connect here. And in this connection object, we can simply specify the ID. And this would be the ID of user 0 .id. And other than the author, we also have a text, which is just test. And we have a title, which is a test title. All right. Now finally the comments. Const get comments. And you know the drill. This time we are dependent on the user adding the comment. So let's again have users here. And we are dependent on the post to which this comment is assigned, right? So let's do post as well. And again, you know the drill, Prisma.comment create input. All right, so that sets up all of our basic data. Now all we need to do is we need to create the function that gets the data and actually pushes all of that to our database. So let's call this the main function. This is an async function. And first of all, let's create all of our users. So users is await promise.all because every single user creation in and of itself resolves as a promise. So let's just have here get users, which returns an array, map every single user. So this is an individual user. And this is where we actually use the Prisma client, right? So we specified the client earlier, client dot. And we can see that for every entity that we have, so for comment, for post, and for users, we have these attributes that we can use or methods that we can call to create these entities. So first of all, we're creating the user, once again, dot. And we have all of the queries and the mutations available to us. In our case, we simply want to create this. And the data we are passing into it is the user in and of itself. So if you're not used to the map functions and the arrow function syntax, that might look a little confusing. Essentially what just happens is we're iterating over the users we're getting here. For every single user, we are calling the client user create method, which is an asynchronous call that returns a type of promise that will complete when this entity was actually created. And we're passing in the user here, every individual user, as data for this method. And the reason we have a await promise.all here is that this will return a list of promises, one promise for every single user that's being created. And this await method simply tells us, hey, wait for all of these promises to finish before moving on, so that this users object is actually the list of all of the created users. Now, we can simply do the same thing for posts, right? And finally, we do the exact same thing for our comments. And this is, again, is why we waited for posts to complete, because in order to get our comments, we are dependent on the users that were created and on the posts that were created. Awesome. Now all we need to do is actually call the main method as part of this file. And we're done. That's our entire seed file. In order to execute this, let's open up our terminal. And in our terminal, we can simply run the command npx prisma db seed. And that should run our seed file. The seed command has been executed. Great. So let's take a look at our studio to make sure that this data actually exists. Refresh the page. Go to users, for example. And we can see our 3 entries, Bob, Charlie, and Steve. Now, this is also something that we can then commit with Git, for example, so that all of our other co-developers on the project can work with the same demo data and easily also add data onto it just by extending this array. And whenever you lose your entire database, all you have to do in order to get it back up and running is you can run db push or db migrate. And afterwards, you can run the Prisma db seed. And you have all of your data back up and running again, and you can just continue working on your project. So now that we have some data in our database, we already know how to write data, which it doesn't matter if you're in a seed file or if you're on your actual backend, the way you would do it is exactly the same. Let's take a look at how we would query data using the Prisma client. So for that, let's just go back to our root here, create a source folder. And inside this source folder, we can create a prisma.ts file. And in this prisma.ts file, we import the same Prisma client we used to create our seed data and instantiate that again. And also let's create a main function that we can just call in a sec and make that async as well. And execute main. So let's say we want to find a specific post, right? So we have const post, and let's await for the response. So client.post, right? That's that we're looking for. And we want to find first. And let's say we want to find where. So you have a lot of options, right? You have distinct, include, order by, select, etc. The where statement is very similar to the SQL where statement. So it defines the filter criteria to apply. So in this case, we're looking for something by the title, and I think we called one test post 1. Let's also make use of some of the other functionality. For example, we can use the include. And in here, we are able to, for example, include the author. And we are able to include the comments. And these are implemented as Booleans, so just add that here. And we can just console.log the output. And finally, let's call the client disconnect function to make sure we free up that connection again. That's it. It's as simple as that. And that's what I love about Prisma is that if you look at post here, you have all of the type completions, right? So if you hover over post here, you see that it has the post object, the author, and the comments. So if you can easily go into post and then author and then get the email of that author with zero typing on your part whatsoever. So let's just quickly run this example by opening our terminal, running ts node, and then this is in source and prisma.ts. Oh, and we need to prefix it with npx. We get a null response. So maybe we had made a mistake in how we specified the title. Let's go back to our Prisma seed. Yes, that was the text, not the title. The title was test title. So let's quickly fix that. Save that again, go back to our terminal and run the command again. And you get the full response, which is just super simple and pretty epic that it works that well. Now, for example, if we want to update that post, we can again use our client. Let's just await that. Client.post.update. And the data we want to update is we want to change the title to new title. And in terms of the where statement, we can just reference the ID because we have that from our previous one. And of course, we can guard this if we have a post. Then we don't need the guarding here. And yeah, that's it. I mean, we can also add this to assign this to a new variable. And also assign this to a new variable. And this new post is post. We can again also do the include statement here if we want all of that additional information again. But I guess in this case we don't need it. Let's add the previous console.log here and add a updated post and change the variable here to a new post. Save that. Go back to our terminal. Run this again. And there we go. We get the original post with the original ID, and we get the updated post. And since we didn't include any of the users or the comments, etc., we just get the post object itself with a new title. So to be fair, Prisma is so amazing that if you ever have the chance of using Prisma to do your querying, updating, inserting, etc., I would always use it. There are some edge cases where with complex joins, etc., Prisma performs more SQL operations in the background than might be strictly necessary. And if you're in a very high performance setting, what you can always do is you can always override the Prisma implementation for certain functions so that you get all of that performance that you might need. But in terms of the type generation, there's just nothing that ever tops Prisma. However, Prisma comes with a limitation. You can only use it on the back end. If you have a purely front-end application and you don't want to have your own API that for example, you're managing, and you want your front end to talk directly to your database through the data API of Supabase, you can't use Prisma. I would still use Prisma for the schema management and the migrations, and for seeding data. But for querying and for interacting with the data from the front end, you would actually need the Supabase client, because what that one does is it talks to the Supabase data API, and that also includes all of the authentication and security mechanisms that you might need. So let's take a look at the Supabase client just for completeness sake, so you get a feel for how that might be a little different. And you also, by comparison, see just how great the Prisma typings are. Though before we write any code with Supabase, we need to import the types somehow, right? The types that we currently have were generated by Prisma and are only available to Prisma. They aren't available to our Supabase client. However, Supabase provides a generate types functionality on their CLI tool that takes the schema directly from the databases that we have created. So open up your terminal and run the following command: npx supabase gen types. Define how you want to export them. So for TypeScript, we want to use our local database, and they are part of the public schema. And these are added to source/types/Supabase types. Before we run that command, let's actually quickly create the types directory and execute the command. Once that is completed, we can check this in our code editor, and we can see that we have some of our types created here. You already see just by the sheer amount of it that it's no comparison to what Prisma does under the hood. So the type definitions for Supabase are a lot simpler. Next up, before we can use the Supabase client, we need to install it. So up until now, we've only installed the Supabase CLI as dev dependency. So now we need to install the Supabase client, which is at supabase/supabase-js. which will be deployed with our application. Okay, so now that that's installed, let's go to our code editor, go back to source, create a new file, and we just call this supabase.ts. In here, we can import the create client from Supabase. And we also need to import our types. So these are included in types/Supabase types. And we want to import the database type, because this will be used when we create our client. So this will look like the following. Create a new client using the database as the template type. And this will need two things. It will need the URL of our data API from Supabase, and it will need some sort of key to authenticate with. If we have forgotten what those are, we can simply run the Supabase status command. We get the data API URL. And because we don't want to implement any user login at the moment, we can just use the anonymous key as a second string. Save that. So this will establish the client connection for us. Let's once again create a main method, which again is async, and query for the same post that we were just querying with in Prisma. Of course, now the title has changed, so now this new title. So const post is await client dot, and you already see that with Supabase we don't have access to the entities themselves, but we have access to a more SQL-like interface. So we will actually specify from. Here we will specify the type of entity that we will use. And we do see a little bit of code completion here. So we do get the suggestion to use one of our entities. In our case, let's do post. And then we perform a select operation, which is we want to select everything. But we also want to select the users and the comments that are linked with it. So in that case, we have to, within this string, and this is something that I don't really enjoy too much about it, is type the query out as you would in part using SQL. Now you do the select operation, and now we use EQ for equals and for our where operation essentially. And this is our title and the title string. Save that, and it gets auto formatted. Right, so you can already see this is a lot more like SQL, whereas Prisma in comparison, this is a lot more abstract and in my mind, a lot easier to work with. Now there's one thing to note here. The Supabase client, it doesn't return promises directly, it returns something called a promise-like, which always resolves, it never rejects. It doesn't return the post object directly, but it returns a wrap around it. So you have the count, the data. So this is more of the post request rather than the post itself. So let's actually call this post request. And where the Prisma client would just throw with an error if it encountered an error, for example, it didn't reach the database, etc., we actually have to check for an error object here. So if post request error, then maybe let's just console.log error and then post request.error. And since we are inside a function, we can just early return. Now, if we don't have an error, then let's do console.log the post request.data. And if you just hover over the data object, we can see there's a lot more of a complex type going on here. So let's just console log that out and run the main method. Open up the terminal, clear out of all of that, npx ts node and source Supabase. Right, and we can see the response. Now it's saying that the fetch API is an experimental feature. This is because we're not actually executing this from within our browser at the moment, which we could, and this is the main benefit of using the Supabase data API, but we are using this from the node context. So this uses node fetch instead of the browser fetch. And this is why you have this experimental warning here, which you can just ignore, because if you're in a server context, then usually you would want to use the Prisma client anyway. That's essentially it. If you're using the Supabase authentication and authorization mechanisms, then if you authenticate via Supabase, it will automatically make sure that once the user is logged in, it will use the user's specific access token to make those requests towards the database. If you are using something like NextAuth to implement your own authentication, and you want to make sure that that access token then gets used from the front end directly to make the request to the Supabase data API, then you have to make sure that your client gets updated with the access token, which I think is in some additional config like auth and then I think access token, something like that, and then you can pass it in here. Anyway, that is a different topic. If you're interested in that, make sure you leave a comment below and we can dive into using NextAuth together with Supabase or your own custom authentication provider the next time around. There is also one thing to note, that if you manage your schemas with Prisma and you frequently update those, then it probably makes sense to, in your package.json, add a script, something like update types, and add the command that we just used, the generate types command, to make your life a little easier when pulling those types after your migration. So the workflow would always be update your schema.prisma file, run db push, create those migrations when you're done and ready to commit those changes, and then afterwards run the update types command to update your local type definitions for your Supabase client, and then update your local client as needed and for your use cases. Great. Now that you're familiar with the core functionality of Prisma and Supabase, you're probably really itching to get started on your next super exciting side project. Luckily, I know a little secret that will help you wrap up the entire full-stack application setup and deployment process in less than 20 minutes. But before I tell you, make sure you leave a like and subscribe to the channel. Got that? Awesome. Well, then you're ready to take a look at this video next, where we will walk through the entire process from scratch to get an app into production, which will also be using Supabase and Prisma. Thank you for sticking around until the end. Have a great day, and as always, happy coding.